Welcome back to our series on Applied Regression Analysis. I'm Mark Ledbetter. This is lecture video 41. We are in chapter 11, part 2. So in the last video, we discussed interaction. We said that if we have parallel slopes, in this case, between two levels of a variable, say c, across the levels of another variable, say t, then we do not have interaction. So we can perform a test to see if the slopes are equal, and that basically tests whether the lines are parallel or not. And if they are equal, then we do not have interaction. If the slopes are not equal, then we have interaction, and there's different degrees of that. In this case, we not only have lines that cross, but we have slopes that are in different directions, and that is certainly a strong case of interaction. That's an extreme case, really. So when we have interaction, regardless of whether the lines cross or not, if they're not parallel, that is still interaction. The rates of increase for one case, or for one level of whatever, say this is C0 and this is C1, they're different. The rates of increase are different. So we have to discuss these cases dependently, I should say. So when we have interaction, we can't just talk about T by itself, and we can't just talk about C by itself. We have to talk about them in terms of each other. So in this case, what we're saying is, let's look at C1. As T changes from T0 to T1, we see that Y will decrease. But for C0, we see that from T0 to T1, that Y increases for C0. So we have to discuss them in terms of each other. Now, in this section, we're going to look at confounding. And we say that we have confounding if we have meaningfully different interpretations of the relationship that we're interested in. When one extraneous or independent random variable that we're not really interested in is included in the analysis or not included in the analysis, okay? And so we're going to only look when we don't have interaction. We're only going to talk about confounding when we do not have interaction between our variable of interest and other independent variables in the model, because interaction really complicates things even further. So if we want to study the relationship between y, our dependent variable, and t, and then also put in some control variable, say c. So in order to look at confounding, and this says assess, but really there is no statistical test for this, so there's no really good method to analyze this. So we're going to have to look at this kind of heuristically, so to speak. All right. So we have the one model that only has T in it, and then we have the other model that has T and C. All right? And again, we're leaving out interaction. So we're going to denote the estimate of beta 1 in the first model as beta 1C. So sorry about the some blurriness here, but this is beta 1C hat. And the estimate in the second model, we're just going to say as beta 1 hat. And so the second model, you notice, doesn't have C in there, but the first model does. So we're saying that this is beta 1 with C included in the model, and this is beta 1 without C. And we say that the confounding exists if beta 1 hat is meaningfully different than beta 1C hat. But again, there's no statistical test for this. So if we have beta 1C hat is equal to 4.1 and beta 1 hat is equal to 15, there's a big difference there. And so we say that we see confounding. There's obviously a difference between 4.1 and 15.9, and so we should account for C. However, if we have 6.2 and 6.1, then we would definitely say that there's no C is not a confounder, is not a confounder. So, and then we could extend this to several what we call covariates as well. So more variables, independent variables here. The problem occurs when we have, so that's straightforward, but the problem occurs when we would have, say, something like beta 1 hat equals 6.1 and beta 1 C hat equals 7.5. So are these different enough to say that we have confounding or not? And that is really dependent upon the number of observations, the amount of variation, and how meaningful those differences are in our minds. Okay, so we've brought up confounding, and we really haven't given you much of a way to test for it. But unfortunately, this is an area where there really aren't any good solutions, but it is something you need to know about. So confounding is something we need to consider and make sure that we account for, especially in cases where it's very obvious. All right. So, and I want to point out that we're looking at these two estimates, and we have this model. What if this beta 2 is not significant, but the difference in beta 1 is very significant between these two models, the beta 1 hats? Then even though this is not significant, we would want to still include it. And so that is the point that we're trying to make in this section. I hope that's a little more clear than what the text is saying here. All right. So please don't forget to scan your lecture notes by midnight of the date listed on the course calendar. If you have questions, come to virtual office hours. If you need help before you can get to virtual office hours, by all means, email me. I am happy to help you. But I'll need two things from you. I'll need a picture of the problem because I may not have access to it. And I need a picture of your work so that I can see your approach to the problem. And then I should be able to help you very easily through email and very quickly. So I hope you'll take care of yourself and stay safe until next time. We hope to see you then.